Hey guys, today we are going over lesson 6. So we rearranged 5 and 6 because I'm not here today, so we'll go back to 5 next week. So today's scatter plots. Quick reminder, or maybe for the first time if you didn't learn this in middle school, a scatter plot is a graph that relates two sets of data. So the purpose of a scatter plot is to see if there's any correlation, meaning if they relate to each other or not. So an example of something that would relate would be like your height and your weight. The taller you are, probably the heavier you are. Obviously, there are some exceptions. So it's not a consistent pattern all the time on a scatter plot, but it's just overall trying to see if there is a relationship between the two sets of data. So I'm going to pause this really quick. Go ahead and label your X and Y axis and come up with a scale that you know for sure will reach all the way through the biggest number and include the smallest number. Okay, I've got mine labeled. It might be hard to read because this pen is hard to use on the computer, but on the y-axis, I went up by tens for the television numbers, and then on the x-axis, I went up by ones. I didn't label every line, but I did go up by ones, and that is the newspaper. So now we're going to plot each point. First one is over to 54 up to 4. So we're going to have to estimate a little bit when it's not an exact line. Over 59 up to 46. Over to 62 and then up to 59. 62 again, up to 76. And again at 92. And then 55 up to 101. So typically there would be a question now about comparing the data, if you notice any type of relationship or not, but for now we're just practicing plotting. So go ahead and go to the on your own problem, pause here and see if you can complete the scatter plot by yourself and then check the answer in a few minutes. Okay, this is the answer I got. Your scale doesn't have to be exactly like mine. So I used a break here, actually both X and Y axis I used a break to show just the numbers I wanted to focus on. Make sure your labels are there. I went up by 0.5 on the x-axis, but only labeled every other one, and then went up by 3 on the y-axis, and that spread it out pretty nice. And make sure you've got these points in the right spot, and that is all for the on your own problem. So now we're actually going to talk about the correlation and how the data relates to each other or doesn't relate to each other. So the first type is positive and negative correlation. So the negative correlation means that the points are going down. Positive means that it's going up. Linear means that the points form a line. It doesn't have to be all in one perfectly straight line. It's just an overall pattern that the points are straight. Nonlinear would be anything else. So a U shape like that one, it could just be a curve going up or just a curve going down. And then strong and weak. So strong would mean that the points are fairly close together. It doesn't have to form a straight line, but they are close. And then weak would mean that there is some relationship, but the points are pretty far away from each other. The next thing is the correlation coefficient. So this is something that's probably new to you. So make sure you underline or highlight anything here that you think might be important. So this is how strong the relationship is. It's a number between -1 and +1. So first, a +1 would mean that it's strong and positive. So the points are close together and they're going up. A -1 is still strong, but now they're going down. And then 0 would be no relationship at all. So the number could be anywhere between -1 and +1. It doesn't have to be just one of these three numbers. So let's practice now describing the correlation. So it's asking if it's positive or negative first, linear or nonlinear, strong or weak, and then we're going to estimate that correlation coefficient. So we're practicing all of this at once. I'm just going to say the answers out loud because it's going to take me forever to write with this computer pen. So first, positive or negative. Because these points are going up, it is a positive correlation. Next one, linear or nonlinear. So because they are forming a line, it's linear. And then strong or weak, they are really, really close together, so that would be a strong correlation. And then the correlation coefficient. So because it's positive, it has to be a positive number. Because there is some type of correlation, it can't be 0. So it's going to be somewhere above 0 up to 1. If it's really, really strong, which this one is really strong, it would be closer to 1. Because it's not a perfect straight line, it can't be exactly 1. So I would say maybe 0.9, anywhere close to that would be correct. So it's an estimation. You're not going to know the exact number. It's just getting close to it. Number 2, so first this is negative because the points are going down. Next, it would be between linear and nonlinear. It is linear because they're still forming a line even though they're not perfectly straight. And then strong or weak, they're not as strong as this one was, but they are still pretty close together. So I would still consider that one strong. Or if you wanted to say maybe it's medium, if you don't feel comfortable going one way or the other, that would be fine. And then the correlation coefficient, because it's negative, it has to be a negative number. Because there is a pattern, it can't be 0, so it's got to be less than 0, and then down to -1. So because I already said it's kind of medium, I would maybe give it a -0.5, maybe -0.6, somewhere around there. And then last one, either positive or negative first. So because it starts up high and goes down low, that would be negative. It's getting smaller. This one is nonlinear because it doesn't make a straight line. And then I would say this one's pretty strong because those points are close together. If it helps, let me try to draw a line through the middle. If you draw a line through the dots, if all the points are pretty close together like they are here, then it would be considered strong. And then the correlation coefficient, because it is fairly strong, is going to be close to 1. Because it's -1. So I would give this one probably a -0.8, maybe -0.9, so anywhere around that area. So go ahead and pause here and try these next few on your own. Make sure you answer all these questions. So you should have 1, 2, 3, 4 answers for these two, and then this one's a little bit different. So pause here. Okay, number 4, I would say negative for sure. Linear, because they do form a straight line. I would say that it's fairly strong. If you wanted to say medium, that's fine. And then the correlation coefficient has to be negative because it's going down. It's not super strong, so I would say somewhere around -0.5, -0.6. Number 5, this one's kind of tricky because it went up and then back down, so you would say positive and then negative. This is nonlinear because it's not a straight line. Again, it kind of is between strong and weak. I would say it's fairly strong just because they mostly follow a pattern. And then the correlation coefficient actually doesn't exist on this one, so that may have been confusing because it switches direction. We can't give one number. And then number 6, this one's going to vary, but I'll just kind of describe it. So for it to be weak, your points would have to be pretty spread out, not all in the same line. Positive means that they're going up, and linear would mean that they are forming a line and not curving. This last thing, I'm actually not going to go through and do all this, but you're just kind of combining everything that we've already done. So you would plot all of these points, describe the correlation, how we just did, and then use the graph to make an estimation. So I'm not going to make you do this. That way you have plenty of time to get some work done. So use the rest of class period to work on today's homework, and then also yesterday's when you get finished. If you have any questions, you can talk to a neighbor or just ask me on Tuesday. Have a great day.